On this one, we're actually going to use the factor theorem and factor that polynomial. The thing we have to think about though is that this tells us what factors to test, and we got to figure out, well, how do we know what factors to test? So first thing I'm going to do is if I want to find out if x minus 1 is a factor of the polynomial, I got to substitute positive 1 in. So f of 1 is going to equal 2 times 1 to the 4th minus 11 times 1 cubed plus 23 times 1 plus 10, which you can just sub that all into your calculator, and I get 24. So then x minus 1 is not a factor. F of negative 1 equals 2 times negative 1 to the 4th minus 11 times negative 1 cubed plus 23 times negative 1 plus 10, and you can just punch that all into your calculator and we get 0. This tells me that x plus 1 is a factor, so now I got one factor of that polynomial. Okay, what I want to show you really quick now though is how to use Desmos to test values really quickly. So whatever the polynomial function is that you're trying to factor or you're trying to figure out remainders or factors for, punch it in as f of x or give it some name and then type it in. So f of x equals 2x to the 4th minus 11x cubed plus 23x plus 10. But then all we have to do is in the next line, hit enter and just go f of whatever value you want to test. So the first one we tested was 1. So I'm going to put in 1 and I get 24. Now all I got to do is put a little negative in front. Oh, it's 0. Now we can test 2 is 0. Negative 2 is 84. 5 is 0. Negative 5 is 2,520. You can just go through the values so very quickly using Desmos now that it's just a great tool for testing. So now that you know how to use Desmos, we're just going to go through all this really quickly. So for C, we're going to find f of 2, which equals 0. So x minus 2 is a factor. For D, because it's x plus 2, I'm going to sub negative 2 in, and I get 84. So that's definitely not a factor. For E, f of positive 5 is equals 0. So then x minus 5 is a factor. F of negative 5 for f, because it's x plus 5, we sub negative 5 in, and we get 2,520, so it's not a factor. G, I'm going to sub in positive a half, so I get 20.25, and that was done on Desmos as well. And then negative a half equals 0, so then x plus a half is a little bit tricky. That is a factor, but that's not usually the way we want to write it, so we're actually got to tweak that a little bit. So now we got 1, 2, 3, 4 factors, and I know this polynomial has highest power 4. Whatever the highest power is, that's the most factors you can possibly have for binomial factors. So I know these are our binomial factors. So I'm just going to write this out and go, okay, 2x to the 4th minus 11x cubed plus 23x plus 10 must equal x plus 1 times x minus 2 times x minus 5 times x plus a half. So this looks good and it sounds good, all well and good, but we have a problem in that if we expand this, we got to get back to the original. So when I look at that 2x to the 4th in front, if I go x times x times x times x, that's where that leading one comes from. Like technically we got to FOIL and we got to expand this completely. It's a really nasty one to expand, but I know the leading coefficient and I know the constant come from certain places. So that leading coefficient, that 2x to the 4th, that first term, always comes from just multiplying all the x's together. And when I multiply these x's together, I get x to the power 4, not 2x to the 4th. Same thing if I multiply the constants. 1 times negative 2 is negative 2, times negative 5 is positive 10, times a half is 5. It doesn't equal 10, so we have a problem. How we deal with this and where the problem is that x plus a half. So what we have to do is anytime you have a fraction, you basically multiply that one factor by the denominator. So if I go x plus a half times 2, I get 2x plus 2 times a half is 1. So it's just like moving that denominator and attaching it to the x is all we do. So instead of x plus a half, we put it as 2x plus 1. And then if we multiply all the first x's in the binomial, I get x times x is x squared times x is x cubed times 2x is 2x to the 4th, which is perfect. When I multiply the last terms, the 1 times negative 2 times negative 5 times 1, I get positive 10. So both work out, and that's just a quick check. So what's important to notice as well is that for our factors is we got to go, well, how do we know what to test all the time? And this is where a trick comes in as well. And we're going to have what's called the rational roots theorem. But what the rational roots theorem says is just what I just told you. Those first numbers always multiply to the leading coefficient. The second numbers in each binomial always multiply to the constant. So whenever we're trying to figure out what we're going to test is we got to look at the factors of the constant and the factors of the leading coefficient. And we'll basically go, oh, it's all the factors of the constant 10. So factors of 10 are 1, 2, 5, and 10. And we always go positive or negative because we don't know if they're positive or negative. But then we actually got to divide those by the leading coefficient because maybe it's a half, or maybe it's 1/5. We don't know. That's what the rational roots theorem says.